In this video, we'll be talking about hash functions. Now, why it's important for us to understand hash functions is because they're actually very used in the blockchain. And for us to understand how the blockchain works, which is the underlying technology underneath cryptocurrencies, we need to understand hash functions. So right now what we're doing is just laying out the groundwork for you to be able to understand the blockchain in a further lecture. Okay? So what are hash functions? Hash functions, the definition is a cryptographic hash function is something that takes an input. So it takes something. That input could be a message, like a string, a word, a number. It could be a file, a dictionary, any type of object. Okay? It has that input. And then it takes it, does some computation with it, and returns a fixed size alphanumeric string. Okay? Which this return value, we call it the hash, or sometimes we call it the digest. Now, hash functions are very easy to compute, meaning it doesn't matter how big your file or message is, it's going to be very easy to compute that hash function, that hash message in a way. Now, good hash functions have several properties. They are efficient to compute, right? So you can give them a big file, a small file, an extremely large file, and it's very efficient to compute, very quick, right? That's very important for a hash function because for the reason why we use them requires them to be quick. They are collision resistant, meaning that if you give two different files or messages to a function, the return values are going to be different. They're not going to be the same. Okay. They hide information about the input and they look random, right? So let's give an example of why we would use a hash function, right? And this is something, as a programmer, I used often. So imagine as a programmer, you have two dictionaries. So two dictionaries, or even if you're not a programmer, you have two dictionaries who have a lot of values, okay? Let's say they have apple, they have apple, they have cat, they have, dog, and two. And they have a bunch of different other words in dictionary one. Let's call this dictionary one. And you have another dictionary or list. Let's say this is a list of items, okay? And then you have another list 2, which has apple, cat, dog, but then it has 3. And then it has some other things. Let's say the other things are all the same. Now, usually if you want to compare these two lists to make sure they have the same items, what you would do is go through each item, say, okay, is this one the same as this one? Yes. This one, these two check out. Okay? Same thing. Cat, oh, same thing. Dog, same thing. 2, 3, not good. These lists are different. Now that's a problem because if you have big items, if you want to compare them to one another, it'll take a long time because you have to check each different value. Now, if instead of comparing the items, I compared the hash value of the items, would be way simpler. So let's say I have a hash function here, and the input for the hash function is this dictionary or this list, right? It could be anything. I take it in and I return a digest or a hash, right? This is the return value. And this might be a alphanumeric number, right? So it could be A1 V5. That's the return. Now, if I do the hash of this list, well, the return, the return is going to be something different. It might be A29B. So all I would have to do is compare these two hashes. And if the two hashes are different, that means these items are not the same. If they are similar, that means the item are the same, right? Because a hash function takes in an item, does some computation, right? And then returns a hash value. Now, as we've said, hash values, a property of hash functions is that they're collision resistant. So if these ones are not the same, the values that they return will not be the same. So I cannot have two different items that give me the same value. So I know for a fact if the hashes are different, the items are different. They're very fast to compute. So instead of looping and going through all the list, all I have to do is just calculate the hash. It takes nanoseconds to calculate, super quick, and then I can be able to compare them, right? Also, if I wanted to guess what the list looked like by looking at the hash, I wouldn't be able to because it hides the information from the list, right? So I can't guess what was in the list here by looking at this, and it looks completely random, right? That fills the properties of a hash function, right? And hash functions are used everywhere, not only for applications like this where you want to compare things, but if you want to secure something. If I'm sending a file online and this file has some information, or let's say, better yet, passwords, how do you guys think companies or websites store your passwords? Let's say you you go on Facebook and you type your password, and your password is, I don't know, your password is pass123, which is a really bad password. Don't ever have a password like this. That's your password. Okay, well, do you think that Facebook is gonna save your password in their database? No, absolutely not. Because if they get hacked, somebody's gonna get your password. So what Facebook does, or other websites, they're gonna do the hash of your password. And the hash of your password is gonna give, again, something completely random, right? And they're gonna save this in their database. Now, if Facebook gets hacked and somebody gets all the hashes, he can't reverse engineer to get your password. He can't do that because this looks random. He can't guess what happened, and he doesn't even know which hash function they used. Most of the time, you can know what hash functions they use, but the hash functions are so strong that even if you know, you cannot reverse engineer them. So he can't know that this is your password, and you as a user, you feel safe because you know that this platform does not have your password. It only has the hash of your password. So next time when you come in and you want to log in, let's say you put in the password pass124. Well, that's going to give you, because here is 123, here is 124. That's going to give you a different hash, right? So then Facebook gets that hash. Maybe it's going to be V982, and they're going to be like, is this the same hash? No, wrong password. Try again, right? Then if you put the right password in, which is pass123, they calculate the hash of that password, and that's gonna give the same thing here. Because if the same item will always give you the same return, right? So then they'll be like, oh, yeah, that's correct, right password, right? And then you can log in. So hash functions are used in multiple applications. To make it even clearer, let's create our own hash function, okay? Let's create our own hash function. Let's say we're gonna create a hash, and we'll call this hash function MTG hash, okay? Because every hash has its own name, right? Now, this function, it has to have an input, which is the message, right? Like we've said. It's gonna do some work on this message, and it's going to give us a output, which is going to be the digest or hash. Now, I just created some random work, and this work, what we're going to do, step one, is we're going to take every letter in our message or number, and we're going to increment it by 1. So if we get an A, we'll convert it to a B. If we get a 1, we'll convert it to a 2. What we're going to do next is we're going to